has an index of refraction of 1.33. The plastic, they say, is 1.500, and air we know is 1.000. And it says you got a fish in here, so this is looking down at it. So here's a fish, and maybe I'll move that fish a little bit farther away. Light is reflected from a fish in the water and has an angle of incidence of 35 degrees. So this light coming from the fish has an angle of incidence of 35 degrees. What angle does the light enter the air? Oh boy, so this is going to be tricky. So let's see, it's going from the water to more dense. Well, let's plug it into Snell's law first of all to see how it's refracted. So N1 sine theta 1 equals N2 sine theta 2. So it's going from the water into the plastic. Oops, 1.50 sine theta 2. So we take 1.33 times the sine of 35. I want to make sure I'm in degree mode. I'm not. That's good. I got it. I'll divide by 1.5. Divide by 1.5. Then I'll take the inverse sine of that. And I get 30.6. So this theta 2 okay. So it's going to refract like that. And this angle right there is 30.6 degrees. Make it do a little better job. So this bends here like that, 30.6. Now I gotta draw my normal in again, and that right there, this angle is also going to be 30.6 degrees because of the alternate interior angles. Okay, now I'm going to run it through Snell's law again. Okay, it's going from the plastic, 30.6. It's going into air. So I take my 1.5 sine. I've already got my answer up there. Divide by 1, take the inverse sine of that. 30. Oops, let me try that again. It doesn't seem right. 1.5 times the sine of 30.6. Sine of 30.6. Divide by 1 and then take the inverse sine of that. Well, divided by 1 is the same. Oh, that seems better. 49.8. So this gets bent like so at 49.8 degrees. What angle does the light enter the air? 49.8 degrees.